Alright, so the first thing we're going to do is take a look at our calendar for this unit. And this unit has a couple different things in them, but all of them go back to two things, which is distance between 2 points and slope. We're doing distance on the coordinate plane, but we want to find those exact distances instead of approximate distances. So what we're going to do first is we're going to spend 2 days learning how to simplify radicals. You guys worked with radicals a little bit last year. Everyone knows the square root of 36 is 6. And last year you would have said the square root of 40 is somewhere in between 6 and 7. But this year we're going to take the square root of 40 and we're going to represent it as a simplified radical, which would be 2 times the square root of 10. And that's what we're going to learn today. So that's what we're adding to what you already know about radicals. So today we're going to simplify, multiply, and divide radical expressions. And then tomorrow we're just going to add on to that and adding and subtracting radicals and have some practice with the other. Then on Tuesday, after we have a day off on Monday, on Tuesday we'll come back and revisit parallel and perpendicular lines. Now parallel you worked on last year. Perpendicular I had added to your summer work. So you guys had to investigate that and discover how to find the equation for a perpendicular line on your summer work. So we're going to revisit that. And then we're going to look at finding the distance between 2 points. Now we're revisiting this also because you guys memorized and used the distance formula last year in Math 8, didn't you? You found the distance between 2 points, and you probably just took that square root of 72 on your calculator and punched it in and got a decimal. So you guys have done the distance formula, but this year we're going to write our answers in exact simplified radical form. And then finding midpoint of a segment. Then we're going to use what we've learned about slope and about distance to classify triangles and quadrilaterals on the coordinate plane, given their vertices. And then the next day, I might give you a quadrilateral and give you 3 vertices and ask you to find the 4th. So I might give you 3 vertices of a rhombus and ask you where the 4th one is. Now we'll review what our quadrilaterals are, but I know we started studying those in elementary school. My 3rd grader just finished a unit on quadrilaterals, and he came home and talked to me about rectangles and the opposite sides are congruent. So, yeah, he was really proud of that word, congruent. I was proud too. So I know we've been doing this a while, so this will be just adding a little more application into what we already know. And then on the 25th, we're going to do a learning task. It's kind of more of a culminating task, actually. About an amusement park, and you'll be able to work in groups on that, and that'll be a graded task. And then the next day, we're going to find a point on a directed line segment that partitions, that divides up that line segment into a given ratio. And then the last thing we'll look at is perimeter and area of polygons in the coordinate plane. So finding the exact perimeter and the exact area of polygons in the coordinate plane. And then we'll have a review, and then a test, and then on this day, you will have completed the coordinate algebra part of this class. And so when you come back in February, yeah, that'll be exciting. We'll start analytic geometry. Okay? So what we'll do is we'll celebrate by getting a new book. Yay! All right. So we have some notes for today. Today we're going to get radical. All right? All right, so these are our notes.
So wait. After this one, can we throw it on?
You can take last semester notes. It needs an help. I want to throw it away because all that material will be covered on your milestone. No, you take the coordinate algebra.
The other break that we was on that all the time.
I didn't know that.
Okay, so I'm going to give you about a minute to copy down these notes. Emily, were you planning on coming in the morning to take over? Are you ready? I'm sorry. Well, yeah, you took the test. And so, yes, I looked at Tuesday. I'm sorry, you did take the test. I was proud of you taking the test yesterday. I apologize. I looked at the wrong day. Nobody was on yesterday.
Yeah, I was like a mix of orange.
Okay, so our radicals are simplified in exact form. Exact means our radicals have been simplified. Exact means there's no decimal approximations. If we do the following things, there are no perfect square factors under the radical. So a factor means something that will divide into it. You can kind of think of it that way. Factor is like, we could rewrite it as multiples, and each multiple is considered a factor of the original number. Like, I could take 8 and break it down into 2 times 4. So the factors of 8 would be 2 and 4. Okay? So when we have no perfect square factors under our radical, it's simplified. When there are no fractions or decimals left under the radical, so we can't have a radical that has a fraction under it or a decimal under it. We'll have no radicals in the denominator of a fraction. So if we had a fraction and it had a number in the numerator that is not a radical, but in the denominator it was a radical, we have to rewrite it. We have to change it. So those are our rules. Now, the first two are things that you did last year when you did radicals. The ones that were perfect squares, you went ahead and took the square root of. So what's the square root of 81? 9. And your teacher may have asked you, the square root of 90 is between what two numbers? 9 and 10. Okay? So this is what you've already done. And you also know your perfect squares 1 to 25. We had to learn those in our summer work. So take about 30 seconds. Go ahead and write down that list. If you don't know one, skip it. Yes. Our first perfect square is 1 because 1 squared is 1. Our next perfect square is 4 because 2 squared is 4.
Oh, we just wrote down.
Write down your list.
I was writing off 1 squared equals. We're just supposed to write off 1.
Oh, yours are right here. Who makes these?
So I put that right in front of the.
I like it.
I don't know past 16. Oh, it's a little past 17.
All right. Check and see how you did.
I did pretty well. I'm smart. I'm playing.
Okay. Yeah, I missed.
Oh no. Maybe I can.
7 cubes. I knew it took you the 7. It's 7 cubes. I saw the 7 in public.
Okay. So these are the numbers that we're going to try to see if they divide into what we're given. If they're a factor of the number you're given. Because if any of these will divide into our radical, then we can simplify. Now, obviously there are more perfect squares, but this unit we're going to do without a calculator. So I'm not going to give you extremely large perfect squares. Because in reality, if you were ever given an extremely large number, you would definitely go to your calculator. There's a couple reasons why we don't use calculators on this section. On part of the AP test, it is no calculator. So we need to understand how to use radicals. A lot of college professors don't allow you to use a calculator. So even though calculators are awesome tools, you're going to have to go through some courses where you're not allowed to use them. So we're going to practice this skill, which is a skill, without the calculators. So your quiz, your test on this would be no calculator. All right. Any questions about these? Anybody get them all? Yes.
Did you?
Yes, I
I learned that you can add the number before and number you're squaring them down together to get the number you're before the second number you're
Share that with me again in your class. Okay. So these are the ones we're going to look at to learn how to do this. We have lots of examples we're going to do. And what you're going to do, what you're going to notice is that as we move along, there's multiple ways to correctly do a problem. And you do it the way your brain thinks the best. Whatever is the easiest route for you is the route you're going to go. I'm not going to tell you, you must do it this way, because there's not a this way is the only way with this. There's lots of correct methods for simplifying radicals. You do what works best for you. To start with, I'm going to stick with discovering what the largest perfect square is. What is the largest perfect square factor, which means what is the largest perfect square that will divide into this number? Look at your list. What is the largest?
14.
Okay, now 14 is not a perfect square.
No, 196.
196 divides into 200.
Oh, no.
220.
100. No,
100. So to be a factor, you have to be able to take that number and write it as a product with another number. So 102 are factors of 200. Okay? So we can think of this, we rewrote this as multiplication. Well, with radicals, if it's multiplying, we could split it like this. So the square root of 100 times 200 we could write as the square root of 100 times the square root of 2. What is the square root of 100? That is a perfect square. What is the square root of 100? 10. So as a simplified radical, the square root of 200 is 10 square roots of 2. 10 square roots of 2. Does that make sense?
Wait. How did 10 square root of 2 equal 200? Oh, it equals the square root of 200. Okay,
It
makes
does.
sense.
It equals the square root.
But I was just thinking of regular 200.
No,
That
no.
doesn't really.
That does not work.
12 or something.
All right. Square root of 32. You guys help me. What is the largest perfect
16.
square? 16. So 32 we think of as 16 times 2, which we can think of as the square root of 16 times the square root of 2. What is the square root of 16? 4. So this is 4 roots of 2.
Is it always 2?
No, and that's why the next one is different. Okay, look at your list, or think about your list, and what is the largest perfect square that divides? 4. 4 divides in there 6 times. So we can think of this as the square root of 4 times the square root of 6, which simplifies to what? 2
Square root of 3.
roots of, does 6 simplify? No. 2 roots of 6. We know the square root of 4. We don't know the square root of 6. Now, 6 seems so even, like it should have a perfect square factor, but it doesn't. When you think of the factors of 6, we've got 2 and 3, or 1 and 6. And none of those are perfect squares. So the square root of 6 doesn't simplify. That's the best we can do. Leave it the square root of 6. Okay, you try 1 and 2.
Wait, so does when we're doing it, does one of them need to be a perfect square? Does
You're finding the largest perfect square factor. Yes. If there is no largest perfect square factor, then it doesn't simplify. Well, if there is no perfect square factor.
Also, it's like, say 17 is just that we don't know 18 is we do is here. This week the no, it gave us news crinkle. You guys just do it.
You were correct, and I have a proof for it.
So should use it on 20
Alright, so 75. You can think of it as 25 times 3. So it's the square root of 25 times the square root of 3. So it's 5 roots of 3. Okay, square root of 20. The largest perfect square that divides into 20 is 4. So we break up 4 as 20 as 4 times 5. So it's the square root of 4 times the square root of 5, which is 2 roots of 5. Yes, Leah? If it simplifies, then it has a perfect square factor. Yes. But sometimes they don't simplify. Like square root of 31. It doesn't. It is simplified. There's nothing else we can do with it. Square root of 10. There is nothing else we can do with it. Because the only factors of 31 are 1 and 31. Neither is a perfect square. And the factors of 10, 1 and 10, no. 2 and 5, no. None of those were perfect squares. So the square root of 31 is already simplified. Both of these are. There's nothing else we can do with them.
So I just already simplified.
Yeah, I probably wouldn't give you one and ask you to simplify it if it already was. Okay, 288. 288. What do you think?
Yes. 144.
144. Good. 144 times 2. Now, do you see how every time I've broken them down? Well, what we're going to get to is this point where we think of 288 as 144 times 2 and go, okay, I can take the square root of 144. The square root of 144 is 12. So that's 12 roots of 2. I can't take the square root of 2 because it's not a perfect square.
Can we do
Okay.
that will have a perfect square and that smaller and the other one?
I'm going to do 72 the wrong way first and show you that it works. So square root of 72. Let's say I thought, ooh, 9 goes in there. 9 goes in there 8 times. And so I said, all right, the square root of 9 is 3. So that simplifies to 3 times the square root of 8. And then I got 8 and I went, uh-oh, 4 goes into 8. Right? How many times does 4 go into 8? 2 times. And so the square root of 4 is 2. And when I bring out the 2, it's all multiplying. It's all multiplying. See, multiplying, 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 all multiplying. So this makes 6 times the square root of 2. Okay, now, if that is the simplified answer, if I had noticed to start with that 72 breaks down into 36 times 2, and the square root of 36 is 6, I get there a lot faster, don't I? So if I recognize the perfect square factor, I get to the correct answer quicker than if I don't, and I just pick a different perfect square. So if I don't choose the largest perfect square factor, then it just takes me more steps. I can still get to the correct answer. I can get to the correct answer multiple ways. Either way. Make sense?
We can do.
Let's do some math.
Okay. Now, 8, the square root of 8 times the square root of 5. I'm going to show you two methods. Because it's multiplication, and you always multiply anything under a radical with anything under the same radical. Well, these are both square roots. I can multiply a cubed root with a cubed root, or a fourth root with a fourth root. These just happen to be square roots. Now, square roots are the only ones that don't have its little number sitting right there. You don't have to put a 2. If there's no number at all, it's assumed to be a square root. But we can have other radicals also. We can have cubed root, fourth root, fifth root, lots of roots. And we may look at some of those later. So the square root of 8 times the square root of 5 is just the square root of 40. Can you think of a perfect square factor that divides into 40? 4. So we think of this as 4 times 10. The square root of 4 is 2. So this is 2 times the square root of 10. Now, don't put the 2 up here. It's not telling me that's what root I'm taking. It's 2 times the square root of 10. So even though I wrote a little high right there, I shouldn't have. There we go. Okay, let's do another method with this problem. I can multiply first and then simplify. Or I could simplify first and then multiply. The square root of 8 breaks down into 4 times 2, doesn't it? And what is the square root of 4? 2. So this is 2 roots of 2 times the square root of 5. Well, this is understood to be how many square roots of 5? 1. So I'd say 2 times 1 is 2. And the square root of 2 times the square root of 5 is the square root of 10. Did I get the same thing?
Yes.
Yes. Okay. So it's whichever one you see first and what's easiest for your brain. All right. Now, with these smaller numbers, this was pretty easy. With larger numbers, you may find it best to simplify first and then multiply. But you pick. You try this one and you pick your method. Either multiply first and then start to simplify, or simplify and then multiply. Okay, let's look at this first method. So we have two methods here. First thing I did was I broke 12 down into 4 times 3. So it's the square root of 4 times the square root of 3. Well, the square root of 4 is 2. So this is 2 roots of 3. Now square root of 20 I broke down into 4 times 5. The square root of 4 is 2. So this is 2 roots of 5. 2 times 2 is 4. Square root of 3 times square root of 5 is square root of 15. This is my answer. Okay, now if we had multiplied them, we got the square root of 240. And for me, without a calculator, the first thing I noticed, because I'm not going to stare at a problem for 6 minutes trying to come up with the easiest way, it's going to be the first thing I noticed. I noticed, ooh, 4 goes into 24. So I said this was 4 times 60. But when I looked at 60, I went, ooh, 4 goes into 60. So I can think about this 2 ways, guys. I can say, okay, the square root of 4 is 2, and the square root of 4 is 2, and 2 times 2 is 4. Or I could go, wait a second, together these guys make 16. And so together, what's the square root of 16? 4. Anytime you have a radical times itself, it equals what's under the radical. So the square root of 4 times the square root of 4 is just 4. Because the square root of 4 times the square root of 4 is the square root of 16. And the square root of 16 is 4. So anytime you have a radical times itself, it just equals what was under the radical. Alright, so here we go. 15 and 35. Now, 15 does not have a perfect square in it. And 35 does not have a perfect square. And without a calculator, if I multiply these, it would be a fairly large number. So I want to take a third way of thinking about these. Let's think about our factors of 15. 15 breaks down into 3 and 5. And 35 breaks down into 5 and 7. So if you look at your two numbers and you see a common factor, that's going to be really nice. Because we can rewrite this as 3 times 5 times 5 times 7. Is it this the 15 and this the 35? And because we had a common factor, the square root of 5 times the square root of 5 is 5. And it leaves a 3 and a 7 under the radical. So it's 5 roots of 21. All right, you try this one. I'm not going to tell you how to do it. You pick your method and give it a try. you would do is you would break down 48 into 12. And then you said 12 was 43. Now I'm not going to take 4 anymore. 4 is a perfect square. And I'm not going to say root this one. 4 is a perfect square. 48 is 4 times 8 on outside of 6. 12. So 8 on the other 12. And then it is no, 12. The square root of 16 is 12. And then you also put that 16. Alright. Okay. Some of you simplified part of it, but if our radical can be divided by any perfect square other than 1, it can still be simplified some more. So, we could have simplified this into 4 and 6 and gotten 2 roots of 6. We could have broken this down into 16 and 2 and gotten 4 roots of 2. But when we multiply these, we end up with square root of 12. And square root of 12 breaks down into 4 and 3. And the square root of 4 is 2. So it becomes 16 roots of 3. Now, if we had thought about common factors, we'd said, what's a common factor for these two? 8. Did you say 8? 3 times 8? And 8 times 4? Then really we're done. Because the square root of 64 is 8. And the square root of 4 is 2. So it's 16 roots of 3. Okay, so did you have to do it this method or this method to get the right answer? No! There are lots of ways. As long as you just have to make sure your radical will not divide by a perfect square. There's not a perfect square that will divide into what's under your radical. Yes, ma'am?
How do you know, like, when you have it, like, 3 times 8, 8 times 4, which one is, like, on the outside and which one goes on the inside?
Okay, so let me break it down so you can see this. I can break this down into the square root of 3 times 8 is the square root of 64 times the square root of 4. Does this thinking make sense for that line? Can you take the square root of 3? Is that something you did last year? No, we don't know the square root of 3. Can you take the square root of 64? Yes. What is it? 8. So if you can take the square root of it, that's when it comes basically out from under the radical. You can take the square root of 4. That's when it comes out from under the radical.
Thank you.
Yes, Rose?
Okay, I don't know what I did, but I got, I don't know how to read it. Under the radical is like 6, and the next root is 2.
You got 2 roots of 6? I'll have to come look at that because you dropped a number somewhere along the way.
I don't think I multiplied. I didn't multiply it on the side, like on the side of it. You know what I mean? Where you have 2 times 8 next to the radical 12. I didn't multiply on the side, then I divided it like that.
Okay, when you separate this number and you take the square root of 4, it has to come out here as a 2.
Yeah.
When you take the square root of 16, it has to come out here as the 4. And so then we multiply those two numbers. And then we multiply those two radicals. But the square root of 12, I wrote it out like that because I was just saving room, can be written as the square root of 4 times the square root of 3. Well, the square root of 4 is 2, and that's how that progresses. Okay? All right. Now this one, I'm going to go through these, and you guys are just going to watch for sake of time because we're running out of time. 2 times 3 is 6. But I've got a square root of 45 here. And I don't want to do 45 times 6. So let's go root row. That's not what I want to do. I want to break down 45 into 9 times 5. Because I can take the square root of 9 is 3. So this is 6 roots of 5 times 3 roots of 6. That's a much better way. 6 times 3 is 18. 5 times 6 is 30. Numbers with numbers, radicals with radicals. Now, the last thing I said is we cannot have a radical in our denominator. And we cannot have a fraction under the radical. I have an entire fraction under this radical. But this means the same thing as this. And the square root of 49 is 7. This fraction actually divides. And so I'm good. I don't have a fraction under there anymore. But this one causes me some problems. Even when I do this, the numerator simplifies, but I'm left with a radical in my denominator. I cannot leave it like this. And this is what you do every time. Whatever your radical is in your denominator, you multiply both the numerator and denominator by that. Well, guys, what is the square root of 2 divided by the square root of 2? 1. Anything divided by itself is 1. So I'm not changing the value. I'm just getting rid of the radical in the bottom. 3 times the square root of 2 is just that. And the square root of 2 times the square root of 2. Now remember, we said whenever we multiply a radical times itself, it's just that number. So the square root of 2 times the square root of 2 is 2. Okay? I have a few more examples I was going to do. I'll post them on my notes for you guys, but we ran out of time. Okay, so your homework is this worksheet. Unit 7, day 1. And that's it for today's lesson. I like Okay, so the last 2 examples, on this one it would just be about multiplying the square root of 5 over the square root of 5. So you get 6 roots of 5 over 5. And this last one, square root of 7 is fine, square root of 2 is not. So we'd multiply the numerator and denominator by the square root of 2. So that gives us the square root of 14 over 3 times, square root of 2 times square root of 2 is 2. So it's the square root of 14 over 6. And we'll see you